Good afternoon, everyone, and welcome to this week's 30 at 3 Live. What we're going to be covering here today is mostly we're going to be talking about the automatic end reactions that SDS2 calculates, but we'll also talk a little bit about inputting our own end reactions, and we'll also look at a little bit about using end reactions that may be imported or stored in Revit. Typically when I say import, it's probably like from another analysis package. So we'll kind of look at that briefly here as well. So I'm just going to start off showing you how SDS2 calculates shear loads for beams to be automatically applied. Now, for most of what I'm doing here, I'm going to be kind of looking at this situation here with my beam on the right-hand side here. We can see it's a W18 by 40 beam, and if I scroll down here to the length, we can see it's a 25-foot length. So that's kind of what I'll look at a lot of these different examples with. Now, to show you where we actually set up and determine what end reactions are applied, I'm going to go into the setup here under the SDS2 Connect tab. And the options that I'm going to be looking at within setup are going to be found in design criteria. So when that opens up here, we'll look at design criteria. And for now, we're talking about shear loads. So the options that we're looking at are right here, the base beam design reaction on. We can base that on a percentage of either the uniform allowable load or our maximum web shear. Okay. So right now we have uniform allowable load selected. We're at 50%. Okay. To figure out what that might actually be, we could refer to Table 3-6 in the AISC 13th edition. And if we were to look at that table for the 25-foot span for a W18 by 40, we should see the maximum is 62.6 kips. If we take that, 50% of 62.6 should be 31.3 kips. If I go ahead and edit my end connection here, and we take a look at the shear load when that's on auto currently, okay, notice the value that gets filled out there is 31.3 kips. Okay, so we're looking at that. Now if we were using LRFD 13th as our design method, this would be a little bit different, as the LRFD value in that AISC book is a little bit different. We'd be using 50% of the LRFD value instead. Okay, so there's automatic. You can change it to whatever percentage you need. Could be 50, 60, 40, whatever's required. We can also, if you noticed in that setup under the design criteria, we also had the option for to base that reaction on a percent of the maximum web shear. So if I go ahead and change this here, I'm just going to change it to maximum web shear. Still going to just leave the 50%. But what's going to happen here, the web shear is going to be calculated as, it'll be 0.6 times our yield strength times the depth of material times web thickness, and then that's divided by omega, or what would be 1.5, and then 50% of that. So in this particular case, it's 0.6 times 50 times 17.9 times 0.315 divided by 1.5, which comes out to about 112.77. If we multiply that times, or take 50% of that, okay, we should get 56.38, and I'll go ahead and edit my connection here again. I'll just have to force a redesign on it since I changed that option in setup. So just simply selecting that, clicking OK is going to force a redesign. When I come back in there, we can see 56.4 rounds up to the nearest tenth there is the load that is calculated for us then. Okay. Now, once a connection is designed, you'll notice just to the right of the shear load we have a maximum. Now that maximum that is displayed here is going to be the max capacity for the connection that is actually designed. You could also see that in the design calculations. If I run the design report for this quick, and we take a look at, we'll just look at our limit states down here, we can see the connection strength shown here is 57.7 kips. Okay, so that's the capacity that was also shown in the connection edit window, and this tells us our connection is okay based on the shear load that is applied. Okay, so based on what's happening here, SDS2 Connect is applying a end reaction, and then based on that end reaction, it's designing a connection to be sufficient for that. Now, what we can also do is I'm going to edit this connection, and we have an option in here that says minimum setup connection. Currently, we're set to automatic. Typically, whenever you see an option in SDS2 Connect that has a setting of automatic, it means that it's looking to someplace in setup to determine what to do. I want to override this, and I want to say, yes, put in a minimum connection. So when I do that, immediately, notice my shear load down here actually changes to 31.8 kips. Okay? What's happening here is SDS2 is putting in the minimum connection, and I'll show you where it gets the information from in a second, and then it's displaying right here the shear load that's applied is the capacity for that minimum connection. We can also see the maximum, which I showed you and explained to you before, is the connection capacity. Over here is 31 point, in this case 81. We're rounding to 2 places there rather than just showing you the 1 decimal place. Okay, so the previous ways we were applying a load, getting a connection designed around that. In this particular case, we're putting in the minimum connection and showing you the capacity. Okay, so where do we get the minimum values? How does SDS2 Connect know what to put in for this minimum setup connection? Well, I'll go back into Setup. And when we get into Setup, over on the left side, second thing in the list there, we have Schedule of Minimums. When we go into Schedule of Minimums, notice we have 2 tabs. First one is for structural members. So this would apply for clip angles, end plates, just about any connection other than a single plate shear connection. We're going to come in here, and based off the nominal depth of our beams, we're going to use the minimum diameter, bolt diameter specified here with the minimum number of rows, and then our top of steel, the first hole. So this is how it's determining the minimum connection. The reason we have 2 tabs there, one is for single plate shear connections. So again, we're basing off the nominal depth. We have our minimum bolt diameter. We have to have another field here, the minimum shear plate thickness we want used, and then the minimum number of row of bolts we want used in that shear connection. Okay. We can also choose in design criteria, if we were to select the minimum setup connection option there, that would be like the default when we had automatic set for that option in the connection edit window, then it would default to actually using the minimum setup connection rather than having to pull that down and specify yes like I did. Okay. Now, tension and compression loads are not automatically calculated for beams. Those are only input by the user. So we're going to kind of skip those until we get to braces. What I want to look at here now would be our moment loads. Okay. Now if we apply a moment to a connection, what SDS2 Connect is going to do is it's going to look to our design criteria here again, and we're going to input a moment load based on the maximum allowable moment and the percentage that we have set here. So here we have 85%. The way we're going to calculate that is take the yield strength times ZX, which would be from the material properties table in your AISC manual, and then we divide that by omega again, which would be 1.67, and multiply that by 0.85 to get, or whatever percentage we have specified right here. Okay, so for our W18 by 40, we're going to actually take 50 times 78.4 divided by 1.67 and multiply that times 0.85, which is our percentage. We should come up with 1995.21 kips. Let's go ahead and apply our moment here. We do get, I said 1995.21. Notice here we have 1995.9 kips. We do see a little bit of a difference, and kind of the reason for that is the ZX value that SDS2 uses a little bit more precise than just to tenth of a decimal place. We go up to, I believe, 4 or 5 decimal places when we're calculating that. So you might see just a little bit of a difference in that. Okay, again, notice over here we get the maximum moment capacity for this particular connection that gets designed. Okay. Now, if a user needs to automatically input their own values in there rather than using what SDS2 Connect calculates, I can do that. If I simply uncheck Auto, I can come over here, increase that. I'm going to increase it just barely above what my maximum shows here. As soon as I hit Tab, notice that maximum capacity will increase. So SDS2 Connect, as soon as I change that, it goes through, designs a new connection. This is the capacity for that new connection that it actually designed there. Okay. Same thing for the moment. Going back to the moment here, I can uncheck that off of Auto, type in here. If I go just a little above that, okay, it's going to redesign that connection, give me the capacity there. One thing too, I might back up here just a little bit just to point out to you, I'm going to set that back to a non-moment. The minimum setup connection and all the ways that I explained how SDS2 Connect will automatically calculate this shear load, that only works when your auto box is selected. Okay, so by setting minimum setup connection to yes, it will calculate that and only put in a minimum connection. If I uncheck auto, it's no longer simply putting in the minimum connection. It will design the connection for around whatever I actually input there. Okay, so I'm going to go back to auto and go back to my moment once again. Now, something I do want to point out to you here, I'm going to increase this to, let's say, 2,500 kips. Right now it's given us a failed message then, says our connection will not fit the column. I want to go back and show you another connection, or excuse me, another option that will affect some of our design here. So I'm going to go back into Setup. So basically what I did there, I increased my moment load to more than the max capacity for this particular beam. Now if I go back into design criteria, notice I have the option here to design moment connections for greater than 100%. If I turn this on, this is going to apply to moment connections framing to our column flanges like we have in this example. And what it's going to do is design the connection on the column side to be greater than 100%. So if I just come in here, notice my failed connection's gone. We get a redesign on that connection, and now we can see we should get a connection here when we get that regenerated. Okay. Again, that's designing on the column side, and it's going up to 125% of the max moment. Just want to show you in the design calculation report for this connection, when we look at that, I'm going to actually look at the extended report here for us. So I'm going to view extended report in Firefox. And if I come down here to the limit states, okay, notice we only have limit states shown in here for the moment for the column information. Now if I go ahead and scroll down here so we can actually see the formulas that are used, notice here the beam moment strength, the calculation for that indicates to us that it's no good. So with that option turned on in that moment load more than the maximum, we're kind of ignoring some of the checks for the beam moment then in that case. Okay, so again there's the beam flange weld that calls out no good. Again, we're just kind of ignoring that since we have that option to design for greater than 100% turned on. So going back in here again, now the next thing we want to take a look at is tension and compression options for our vertical braces. I'm just going to kind of slide over here and take a look at our brace connection here. So what we have in here, notice we have automatic now for our tension load. Currently we have 77.8 kips. Where's that coming from? Well, go back into my setup again. Again, we're going to look in design criteria. And over on the right-hand side of this window, we have percent of allowable tension load for horizontal braces, allowable compression load for horizontal braces, and then the same two options for vertical braces. So we kind of have that split out a little bit, and we're just calculating based on the allowable tension load the percentage that we have set here. So in this example here, with my double angle brace, the formula is going to be the yield stress times the brace gross area, again divided by omega, and times that percentage that we had set. So in this case it would be 36 times 7.22 divided by 1.67. That comes out to approximately 155.64. 50% is 77.8 kips, which is what is actually being displayed in here then. You can also choose to do your automatic for your compression there if you need as well. Again, it would be the 50% or whatever percentage we had set up in those options that I just showed. Okay. Again, you get your maximum capacity for that set over here. If I increase that, we're going to do a redesign. Notice that maximum goes up as I do the redesign on it. So, okay. Now, another thing that we're going to automatically do for you here a little bit is with the beam connection, since we have the brace framing to that, remember SDS2 Connect uses the uniform force method to design these types of brace connections that transfers forces into the beam to column connection. And if I edit this beam connection in my maximums, I can see over here the interface load is what is actually added into the auto-calculated shear load or whatever I have input here. So the interface force, the interface load comes from the forces transferred from the vertical brace. Notice we also have some axial load. In this particular case, we have compression load also transferred from that brace to design the connection. So we're automatically adding those in there. Now, the reason we're automatically adding those in there, we actually do give an option for that. Again, I'm going to go back into Setup, and I'm going to look at the design criteria. The option over on the right-hand side here, that's checked, add gusset beam interface forces to beam. Since that is checked, that's what tells SDS2 to go ahead and automatically add those interface forces to our beam to column connection. If we wanted to use special case 2 of the uniform force method to do this, there's an option, redistribute gusset beam interface force to the gusset column connection. If that's turned on, we'd basically be using special case 2 where more of that force is transferred and accounted for in the gusset to column connection. Okay. With that one, we can also change that on a case-by-case basis by editing the brace connection. Okay, we can change the option down here, gusset beam force to gusset column. We can set that to yes. And now, when I say OK, notice we get a redesign. If I edit my brace connection, notice the shear load up here. The interface load is now at 0 kips. So that is actually being accounted for now in the gusset to column connection rather than the beam to column connection. Kind of have to watch out for those interface forces a lot. The reason being is a lot of times with the extra force added, you do tend to get some failed connections for your beams. So just something to watch out for there. Now the last thing I want to go ahead and look at is using end reactions that may be stored within Revit itself rather than just in the SDS2 Connect. So I actually have a different model that I'm going to use for this. And this model was actually imported from RAM. Okay. Now what RAM will do is if I go ahead and select this beam, take a look at the parameters over here under the properties. Okay. We actually have a couple different parameters in here, the end reaction total and start reaction total. What we can do is if there's values stored in these particular parameters, SDS2 Connect can go ahead and use those and apply those to the appropriate connections that it needs. Okay. We give an option for this so it doesn't always have to use those when they're present. So if I go into my options here, and actually I'm going to back up one step, I'm just going to go ahead and edit this beam first, and I'll go ahead and edit the connection. Notice right now we just have a shear load of 42.9 kips. It is on auto. Okay. So what I'm going to do is I'm going to go into options, and we have this option in here to use Revit end reactions. I'm going to go ahead and turn that on. Say OK. It will go through. It'll go through all of these and update. This is going to apply, currently this applies to beams, and it can only take those reactions that I showed you there and apply those as a shear load to the appropriate beam connection. So now if I edit this connection again, now notice we have 60 kips shown here. Okay. Auto is unchecked. Auto will be unchecked when we do that. Notice I can't change that. Okay, it's always going to use the value stored in the properties as long as that option is turned on. What I can do is I could come in here, select that beam, and if I change the value in here, so let's say I come in here and I'll change that to 75 kips. I can go ahead and edit this connection, and notice our shear load then is updated to the 75 kips that I updated over in the properties. Okay. If I come in and now I turn that option off to use Revit end reactions, okay, and now I take a look at the connection that's taken off of auto and uses what was originally brought in for that then. And now I could update that if I needed to, just like I normally would through Connect there. Okay. The other thing we can do, and there is an entire webinar on this process, so you can watch it on our YouTube channel or on the SDS2 Connect website. We can also import forces from CSC's Fast Track. That one is a little bit more complete in that it will import shear loads, moment loads, axial loads for beams, columns, braces, just about everything. So we get a little bit more with that. Okay, so that's kind of my spiel on the end reaction input. If you guys have questions here, I'll go ahead and spend a few minutes, take some questions. If you want to use the questions pane over there on your webinar toolbar, go ahead and type it in there. I will answer best I can here. And it can, this can be anything related to what we've shown here today, or just anything Connect in general as well. So go ahead and ask away. I'm going to actually close this one model that I have open here and go back to my other smaller one to work with. Okay, so does anybody have any questions then? So one question I'm getting here is, can the software design complex connections, complex nodes? I guess that's a pretty broad question. We do have a lot of different connections that we can design. You know, kind of what we're seeing here is just a very basic set of some of the connections that we can do. Pretty simple ones shown, but we do some more complex ones than what we see here. Like I said, the question's pretty broad, so you kind of get a broad answer in that sense. But yeah, there are some, depending on how complex you're talking, we do more complex than what we see right here, but it does have some limits. So another question here is, can one use both Revit loads and SDS2 Connect loads on different beams? So kind of the answer with that would be, yeah, you can. What happens is if that option that I showed you to use Revit end reactions is turned on, we look to the end reaction total and start reaction total parameters, and if there is a value present in those parameters, we'll go ahead and apply that to the appropriate beam connections. Okay, if there is not a value present in there, we just default and go back to calculating the automatic load like I explained at the beginning of the webinar, or you can input whatever you need there. Now you can kind of use that a little bit differently too, like I showed you. Once you turn that on, it reads those in. If you need to adjust it from there, you can go back in and turn it off. It still leaves those loads that were stored in Revit applied, but then at that point allows you to change them. So yes, you can use both Revit loads and the Connect loads on the different beams. Okay, any more questions here? Again, like I said, could be anything related to what we did today or just anything else Connect related. Okay, if not, questions are pretty slow today. That's all right. If you guys have any other questions that come up, feel free to email us. Best way to do that would be to email support@sds2connect.com, and I'll try and get a answer out to you if you email me that way. So everybody have a good day. Look forward to seeing you all at the next 30 at 3 webinar.